San Andreas Fault.
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 There hasn't been a big earthquake on the southern San Andreas Fault for a long time, and we may have found a reason why.
The San Andreas Fault, a ticking time bomb beneath the surface of California. The San Andreas Fault, responsible for some of the deadliest earthquakes in U.S. history, and it's only a matter of time before it strikes again. The San Andreas Fault, an 800-mile stretch of danger, where the Earth's plates are locked in a terrifying dance. The San Andreas Fault, where tension has been building for over a century, waiting to explode. The San Andreas Fault scientists say it's not a question of if, but when. How prepared is California for the next big earthquake? The San Andreas Fault has always been a looming threat, with scientists and residents wondering not if, but when will the San Andreas Fault finally trigger the next catastrophic event. In this video, we'll dive deep into the alarming facts and signs that suggest a major earthquake could be closer than we think. Before diving deep into the looming threat of the San Andreas Fault, it's important to understand that dangerous fault lines are not unique to California. Around the world, several fault lines have the potential to cause catastrophic earthquakes, each with its own history of destruction. One of the most infamous is the Sumatra-Andaman Fault in Indonesia. This fault was responsible for the 2004 Indian Ocean earthquake and tsunami, a magnitude 9.1 event that devastated the region, claiming over 230,000 lives across multiple countries. This event highlighted the destructive power of subduction zones, where one tectonic plate dives beneath another, releasing massive amounts of energy. Another treacherous fault is the Alpine Belt, which extends from the Himalayas to the Mediterranean Sea. This fault system is known for causing significant earthquakes in countries like Turkey, Iran, and Greece. Earthquakes along this fault can be devastating due to the high population density in these regions, making them particularly vulnerable. The Cascadia subduction zone, located off the coast of the Pacific Northwest in the US and Canada, is another ticking time bomb. Capable of producing magnitude 9.0 earthquakes or higher, this fault also has the potential to trigger tsunamis that could impact coastal communities from British Columbia to Northern California. Experts are closely monitoring this zone, as a rupture here could be catastrophic for cities like Seattle and Portland. The Himalayan Fault is another seismic hotspot responsible for forming the mighty Himalayas. This fault regularly produces significant earthquakes, such as the 2015 Nepal earthquake, which measured 7.8 on the Richter scale and resulted in widespread devastation, leaving thousands dead and many more homeless. In Turkey, the Eastern Anatolian Fault has been a source of deadly seismic activity for centuries. The most recent earthquake in 2023 devastated southeastern Turkey, illustrating how active and dangerous this fault remains. Finally, the San Andreas Fault in California, running 800 miles along the west coast, is one of the most well-known fault lines in the world. Californians are haunted by memories of the 1906 San Francisco earthquake and the 1989 Loma Prieta quake. Scientists warn that a rupture in this fault could result in a magnitude 8 earthquake or higher, with catastrophic consequences for California's densely populated areas like Los Angeles and San Francisco. For Californians, just the mention of this fault brings back haunting memories of the 1906 San Francisco earthquake and the 1989 quake that rocked the state. Scientists have long monitored the fault's activity, but recent discoveries suggest the stress building up in the system could soon result in a magnitude 8 earthquake or higher. Could this be the event that causes California to sink? While that may sound like something out of a movie, the real threat is the massive destruction that could follow an earthquake of this scale. If the San Andreas Fault were to rupture, the impact on California's densely populated regions could be catastrophic. Major cities like Los Angeles and San Francisco are directly in the path of potential disaster. With infrastructure, including highways, power lines, and water systems, running through or near the fault line, a large quake could lead to widespread damage. The economic costs alone could reach hundreds of billions of dollars, not to mention the human toll. Experts predict tens of thousands of injuries and potentially thousands of deaths in a worst-case scenario. Even though California has made significant strides in earthquake preparedness, including early warning systems and infrastructure reinforcements, the magnitude of the potential disaster makes it clear that ongoing efforts are needed to protect lives and livelihoods from the inevitable big one. Vulnerable areas and the tsunami threat point. Reyes Station, Desert Hot Springs, San Bernardino, and Palmdale are just a few of the vulnerable areas along the San Andreas Fault that could face catastrophic damage in the event of a major earthquake. These regions lie directly along or near the fault line, making them highly susceptible to the intense shaking that a high-magnitude earthquake would produce. However, the danger doesn't end with the ground shaking. Some experts warn that a major rupture could trigger a secondary disaster, one of the largest tsunamis in recorded history. While tsunamis are generally associated with subduction zones, like those found in the Pacific Northwest, the San Andreas Fault's complex seismic activity means that the possibility of a tsunami cannot be ruled out entirely. Coastal regions, such as Point Reyes Station, closer to the Pacific Ocean, could be particularly vulnerable. If the fault's rupture interacts with the offshore faults or triggers underwater landslides, a tsunami could rapidly form, slamming into California's coastline with little warning. Coastal cities, with their dense populations and busy ports, would be at extreme risk. The last major rupture of the San Andreas Fault, the 1857 Fort Tejon earthquake, registered at a magnitude of 7.9 and caused widespread damage across Southern California. However, the population at that time was sparse, and infrastructure was minimal compared to today. Fast forward to the present, and California's population has skyrocketed, with major cities, critical infrastructure, and highways now standing directly in the fault's path. Hospitals, schools, power plants, and water supplies could be critically damaged, leading to cascading failures in public services. Every second counts in the aftermath of a quake, and without proper infrastructure resilience, the consequences could be disastrous, extending beyond just structural damage to include massive human loss, long-term displacement, and economic collapse. With some of California's infrastructure not fully prepared for a seismic event of this scale, the stakes have never been higher. Even with earthquake retrofitting, early warning systems, and preparedness drills, the sheer scale of a potential disaster from a magnitude 8.0 or higher quake, compounded by the tsunami threat, would overwhelm emergency response teams. The challenge of evacuating millions of residents from both inland and coastal areas would be immense, leaving little room for error. This makes the need for continued investment in disaster preparedness and resilient infrastructure more urgent than ever. The Silent Springs. What has many experts particularly worried is the silence. Parts of the San Andreas Fault haven't moved in over a century. Stress is building up, and scientists are urging California to prepare. Thomas Jordan, director of the Southern California Earthquake Center, said that the fault is locked, loaded, and ready to go. The question isn't if it's when. This long period of seismic inactivity, known as seismic silence, is a ticking time bomb. The longer the fault remains quiet, the more energy is stored, increasing the chances of a massive rupture. When the fault finally does give way, the force of the quake could be significantly stronger than expected. This is why experts are calling for immediate action to reinforce infrastructure, improve emergency response systems, and educate the public about earthquake safety. Could California handle the aftermath of such a powerful quake? With millions of people living near the fault, preparedness is critical to minimizing the devastating impact of the inevitable big one. If you're finding this information crucial and want to stay updated on this and other natural threats, don't forget to hit the subscribe button and click the notification bell. We'll keep you informed on the latest research and tips for staying safe in the event of an earthquake or other disaster. Emergency readiness. Los Angeles has taken important steps to retrofit buildings and prepare for a major quake. Mayor Eric Garcetti has led efforts to strengthen older buildings and prepare for the worst. But is it enough? The USGS estimates that a 7.8 earthquake on the southern section of the San Andreas Fault could cause up to 50,000 injuries and over $200 billion in damages. Entire regions, like the Coachella Valley and Inland Empire, could experience shaking for up to 2 minutes. Can California's cities really withstand a magnitude 8 quake? The reality is that while some preparations have been made, there's still a long way to go. Strengthening infrastructure like aqueducts and telecommunication systems is crucial to reducing the loss of life and property when disaster strikes. The San Andreas Fault, a geological masterpiece. The San Andreas Fault is more than just a ticking time bomb. It's a natural wonder. It's visible in places like San Luis Obispo County and Marin County, where the ground visibly shifts. It's also a testament to the immense power of tectonic plates, which move at a rate of just a few inches per year, but can release incredible energy during a quake. The San Andreas Fault marks the boundary between the Pacific Plate and the North American Plate, creating one of the most complex and fascinating geological systems on Earth. These plates are constantly grinding past each other in a process known as strike-slip motion, where horizontal movement builds tension over time. When the stress becomes too great, the plates slip abruptly, causing earthquakes. What makes the San Andreas Fault so unique is its ability to produce both small tremors and catastrophic quakes that can reshape entire landscapes. Geologists and scientists are captivated by the fault's ability to show how Earth's crust is in constant motion. Along some sections of the fault, visitors can see dramatic pressure ridges, linear valleys, and scarps, evidence of past earthquakes that have shaped the California landscape. The Carrizo Plain, for example, is one of the best places to observe these features, where visible shifts in the land provide clues to the fault's violent history. Despite the risks, the San Andreas Fault also serves as a valuable educational tool for geologists, offering insights into the mechanics of plate tectonics and earthquake prediction. How does the San Andreas Fault continue to shape California's future? Beyond its potential to trigger massive earthquakes, the fault plays a significant role in shaping the physical environment. The constant movement of the fault has created dramatic landforms such as the San Gabriel Mountains, which were uplifted over millions of years due to tectonic activity. Even though this geological process unfolds over long time spans, the consequences are visible today, and the ongoing tectonic shifts will continue to alter California's landscape for centuries to come. As we learn more about the fault and its behavior, scientists hope to improve earthquake prediction and preparedness. Understanding how this geological masterpiece functions could hold the key to safeguarding lives and property from future seismic events. What to expect from the next big one? Scientists have simulated what a massive quake could look like. A magnitude 7.8 quake would send seismic waves from the Salton Sea to the San Gabriel Mountains, shaking major cities like Los Angeles for minutes. The simulations show how long-lasting and widespread the shaking could be, especially in areas with soft soils that trap seismic waves. These simulations are not merely theoretical, they are built on extensive data collected from previous earthquakes and detailed knowledge of the geological structures surrounding the San Andreas Fault. A major earthquake like this could shake the ground for up to 2 minutes, causing widespread destruction. Buildings, roads, and infrastructure would be severely damaged, particularly in older areas where structures may not meet the latest earthquake-resistant building codes. Experts predict that much of the damage would occur in the Los Angeles basin, where sedimentary basins amplify seismic waves, creating longer and more intense shaking than in bedrock areas. Could California's infrastructure withstand such an event? California has made significant efforts to prepare for the big one. Retrofitting projects, particularly in Los Angeles, have focused on strengthening vulnerable buildings, especially older structures and high-rises. Additionally, emergency preparedness plans have been developed, with drills conducted regularly to train first responders and residents on how to react when a major earthquake strikes. However, despite these efforts, the sheer scale of damage predicted by the simulations is overwhelming. A magnitude 7.8 quake could cause catastrophic effects on critical infrastructure, including water supply systems, electrical grids, and transportation networks. Bridges and highways that connect cities across the state could collapse or become impassable, hampering rescue and recovery efforts. Power outages could last for days, and essential services, like hospitals, may become overwhelmed with casualties. The state's emergency management systems, although robust, would be tested to their limits. In addition to structural damage, the risk of secondary disasters looms large. Landslides could bury entire neighborhoods, especially in hillside areas. Fires sparked by ruptured gas lines or electrical failures could spread rapidly in densely populated areas, much like what happened during the 1906 San Francisco earthquake. Moreover, a tsunami could threaten coastal regions if the quake occurs near the ocean. The big question remains: how soon could the San Andreas Fault unleash its full potential? While predicting earthquakes is still beyond our current technology, experts agree that Californians need to prepare now. Recent discoveries, interconnectedness of the San Andreas and San Jacinto faults. Could the San Andreas and San Jacinto faults trigger each other? The recent discoveries regarding the interconnectedness of the San Andreas and San Jacinto faults have revealed that these two major fault systems, previously believed to operate independently, actually interact in complex ways. This interaction raises significant concerns for seismic hazard forecasting in Southern California. Researchers from UC Davis used advanced seismic monitoring and modeling techniques to study the behavior of the San Andreas Fault, SAF, and the nearby San Jacinto Fault, SJF. Both faults are critical components of California's complex tectonic system, with the San Andreas Fault being the more well-known due to its role in major historical earthquakes, while the San Jacinto Fault has been relatively quieter, but still active. The new data showed that seismic events along one fault could influence stress levels along the other. This fault coupling phenomenon occurs because stress is not confined to a single fault line. Instead, the movement of tectonic plates along one fault transfers stress to the adjacent fault, which can either accelerate or delay an earthquake on that secondary fault. For example, if a significant earthquake occurs on the San Jacinto Fault, the sudden release of stress could destabilize the already tense San Andreas Fault, potentially leading to a cascading series of earthquakes. This discovery has important implications for predicting earthquakes, as scientists must now account for the interactions between these two fault systems. The San Jacinto Fault has experienced smaller earthquakes more frequently than the San Andreas Fault, but the interconnectedness suggests that even a moderate quake along the San Jacinto could escalate tensions on the San Andreas. In the worst-case scenario, a rupture on the San Jacinto Fault could trigger a domino effect, releasing built-up stress along the San Andreas, which has been accumulating pressure for over a century without a major release. This could result in a large-scale earthquake, commonly referred to as the Big One, that would have devastating consequences for Southern California. The interconnected nature of the San Andreas and San Jacinto faults presents a new challenge for scientists and emergency planners. Predicting earthquakes is already difficult, and this newfound complexity adds another layer of unpredictability. Seismologists must now consider not only the behavior of each fault individually, but also how they may trigger one another. This research highlights the importance of improving early warning systems, reinforcing critical infrastructure, and educating the public on the possibility of simultaneous or closely timed quakes along both fault lines. Additionally, cities near both fault zones, such as Los Angeles, San Bernardino, and Palm Springs, are at a higher risk due to their proximity to both faults. By understanding how these faults interact, scientists aim to better forecast seismic events, though the timing and exact outcomes remain unpredictable. What is clear is that the interconnectedness between the San Andreas and San Jacinto faults significantly raises the stakes for earthquake preparedness, making it more urgent for Southern California to bolster its resilience to potential seismic activity. Recent discoveries: seismic wave attenuation as a potential earthquake predictor. Recent research on seismic wave attenuation as a potential earthquake predictor has provided crucial insights into the Parkfield region, a well-known site for recurring seismic activity. Scientists have been examining how seismic waves lose energy, attenuation, as they travel through the Earth's crust, offering a new method for predicting earthquakes. Before the 2004 Parkfield earthquake, researchers observed a marked change in wave attenuation patterns. Low-frequency waves showed an increase in attenuation, while high-frequency waves decreased their attenuation approximately 6 weeks prior to the quake. These fluctuations are thought to result from increasing strain within the fault zone. The longer cracks formed in the rocks from accumulated stress relieve some of the built-up tension, while shorter cracks close under pressure. By monitoring these attenuation changes, scientists hope to develop more accurate prediction models for when an earthquake might occur. This technique offers a new dimension for predicting earthquakes, as the attenuation patterns provide a direct reflection of how stress evolves in fault zones. The Parkfield region, in particular, is of high interest, as it is believed to be nearing the end of its current seismic quiet period. Researchers anticipate that another earthquake could be imminent, though the exact timing remains uncertain. This ongoing research aims to refine our understanding of how seismic waves behave in relation to fault line stress, offering a potential early warning mechanism for future quakes. If successful, seismic wave attenuation monitoring could significantly improve our ability to predict and prepare for major earthquakes in fault-prone regions worldwide. Recent discoveries: rapid stress buildup on the San Andreas Fault. Is stress building faster along the San Andreas Fault than previously thought? Recent studies utilizing advanced satellite imaging and GPS technology have revealed that stress is accumulating more rapidly along sections of the San Andreas Fault than previously understood. This new data, particularly focused on Southern California, suggests that even during periods of seismic quiet, the fault continues to build significant tension. These findings indicate that the fault may be closer to a rupture, increasing the likelihood of a major earthquake sooner than expected. Scientists warn that this accelerated stress buildup demands urgent attention to earthquake preparedness, including infrastructure reinforcement and public safety measures, as the risk of the big one grows. Recent discoveries: increased creep along the San Andreas Fault. A sign of impending disaster is the San Andreas Fault experiencing increased creep, Recent research has highlighted increased creep, the slow, continuous movement of tectonic plates along specific sections of the San Andreas Fault, particularly near the Salton Sea. This unusual activity has raised questions about whether this creeping could be relieving stress on the fault or setting the stage for a major earthquake. While creep generally reduces stress, scientists fear it might instead indicate that a larger seismic event is imminent. The increased movement is seen as a potential precursor to a more significant rupture, as it might be redistributing stress along other, more locked sections of the fault. Recent discoveries: underground water and the San Andreas Fault. Could underground water be weakening the fault? Recent research suggests that groundwater extraction and natural seepage may be contributing to subsidence or the sinking of land along the San Andreas Fault. This subsidence, caused by water being removed for agriculture and urban use, could be weakening sections of the fault, lubricating fault lines, making them more prone to slipping. Some scientists believe this reduction in friction could lead to an increase in smaller, more frequent quakes, but it also raises concerns about the potential for a larger, more devastating rupture. The interplay between groundwater extraction and fault dynamics could accelerate the fault's eventual rupture, heightening seismic risk. How long would recovery take? Experts estimate that full recovery from a quake of this magnitude could take years, if not decades. Beyond the immediate destruction, the long-term economic impact would be immense, with billions of dollars needed to repair and rebuild cities. Communities would face months of displacement, and businesses could be crippled by the widespread damage. While California has worked tirelessly to prepare, the reality is that a massive earthquake along the San Andreas Fault would alter the state in ways that may take generations to overcome. Thanks for watching. That's it for today's deep dive into the San Andreas Fault and the looming threat it poses. If you found this video informative, give us a like and don't forget to subscribe for more explorations into the world's biggest natural threats. Stay safe, stay prepared, and thanks for watching.